Hey everyone, welcome back to another Algebra 1 tutorial. In this video, we'll be going over basics of polynomials and exponents. So the key concepts are integer exponents, rational exponents, and polynomials. Integer exponents. Integer exponents are basically a number divided by itself a specific number of times. It is usually written as a power, like 3 to the power of 5, where 3 is the number which is being divided 5 times. And multiplied by itself 5 times, like in the power superscript. However, apart from positive whole numbers, exponents can be decimals, 0 or negative. In this unit, we will only go over 0 / negative / positive / whole number. Zero exponents always end up in the number being 1, like 3 to the power of 0 is always equal to 1, or any number to the power of 0, including 2, 100, and so on. Negative exponents, on the other hand, cause the number to become a fraction, unless the number is already fraction. And in that case, it becomes a whole number, which basically means, suppose we have 3 to the power of negative 2. What this basically is 1 over 3 squared, which is 1 by 9. Similarly, suppose instead we have 1 by 3 to the power of 3 by 2. Here, on the other hand, it would be 1 by 3 in fraction form. So basically what you do is 1 by 3 into 3 by 1. Or, in better words, you make 1 by 3 into a whole number. So here what we're doing is putting it down. So we're doing 3 by 1 into 1 by 6. So here what we're doing is we're taking it from here and making it go up. So it instead becomes 3 squared, which becomes 9. So if we had 1 by 3 to the power of negative 2, it would become 9. But if we had 3 squared to the power of 3 to the power of negative 2, we would have 1 by 9. So here's the diagram which explains it. So we have x to the power of negative n. And if x is not equal to 0 and n is an integer, then x to the power of negative n is 1 by x to the power of n. And 0 exponents, x to the power of 0 is equal to 1. So now let's do a few problems. So 6 to the power of negative 2, which is 1 over 6 to the power of 2, which is 1 over 36. 3 to the power of 0 becomes 1 because, so 3 to the power of 0 is 1 because any number to the power of 0 becomes 1. 4.2 to the power of 0 is 1 as well. So, however, negative 3 to the power of negative 3. So for these ones, we would obviously first make this into a fraction. However, here, the negative sign would stay if there's no brackets, that is. But since, let's just say that there are brackets, then here, you would take out the negative sign. So if there are any brackets before you do it into negative, like to the power of negative 3, then you can remove the negative sign. However, in any other case, suppose it was instead negative 3 to the power of 3, then the negative sign would stay and it would become negative 1 to the power of 3 to the power of 3. So 3 to the power of 3 would give you 1 over 3 into 3 is 9, and 9 into 3 is 27. So negative 1 by 27. Here, on the other hand, it would just be 1 by 27. And so here's an example problem. So suppose we're given something like 10 by x to the power of 10 or 5x to the power of 10 over d to the power of negative 3. So whenever d to the power of negative 3 is on bottom, or if it's on the top, so if it's on the bottom, it would go to the top and vice versa. However, suppose we made this negative 10. So you would think we would do d to the power of 3, and then since x is negative 10, it would go down. But since 5 is a part of it, it would be 5x to the power of 10. So the problem here is that 5 is not a part of x. 5 is just 5 into x. And since x is in power of negative 10, it would go down, but 5 would stay. So instead, it would be 5d to the power of 3 over x to the power of 10. So that's an important thing to remember. So next, let's go over rational exponents. So the radical symbol, aka the square root symbol, which looks something like this. So what this symbol basically does is, suppose we have root 4, it would be 2. Since what number makes 4 when multiplied by itself? So 2 would obviously be the number. So similarly, root 8 would, suppose we had root 8 instead, we'd get no value since 8 is not a perfect square. So it would be some type of decimal. So there would be no positive value for this, which satisfies. On the other hand, there's also something where this is possible. So suppose instead of just square root 8, we have 3 over here. What this makes it do is it basically says what number multiplied by itself 3 times can give 8, which is 2, because 2 and a 2 is 4 and a 2 is 8. So 3 root 8 would give us 2. So this is how roots work. And what you can basically think of roots is, so suppose we have b as a number, and root b is basically, so what it basically is b to the power of 1 by 2. And here's a diagram to display it. So as you can see, a number raised to the power of 1 over n is equal to the nth root of that number. Okay, similarly, the definition of b to the power of m over n. So when a number is raised to the power of b into m over n, is basically to the nth root of that number raised to the m power. So it's basically this. So suppose we have b to the power of 1 by 2, it's basically root b, because it's b to the power of 1, but the square root of b to the power of 1, and b to the power of 1 is b, so it would just become root b. Is what we do for variables. And here's a little diagram. So when x is positive and n is even, then so x is positive, n is even, then x to the n power of n is positive, and n to the power of x to the power of n is also positive, since both of them, since this is even and this is positive. So here's a diagram to display like all the different combinations. So suppose x is negative, so negative 5, and n is even, and x is positive, and x to the power of n is positive, because a negative number to the power of a positive number or even number would always give you a whole number, because x to the power of 2, even if it's negative 5, negative 5 times negative 5, the negative symbols cancel each other out and it becomes 25, which is a whole number. On the other hand, suppose we have a positive and odd, then it would stay positive, it would stay positive. But suppose we have a negative number and n is odd, so we have negative 5 to the power of to the power of 3. So negative 5 power of 3. On the other hand, negative 5 into 5 and negative 5 would give you 25, which is whole. But 25 times 5 would give you 125. But since the third 5 is also negative, it would be negative 125. So what basically is negative 5 times negative 5 times negative 5. So let's do a few problems. We have 8 to the power of 1 by 3. So we did this one before. It's basically 8. So 8 root 3, which is basically 2. On the other hand, suppose we have 1 to the power of 1 by 9. So I said before, this is basically 9 and 1, which what number multiplied by itself 9 times would give you 1, which is 1, because 1 into 1 is 1, and it can go infinitely with the product staying as 1. And let's do this addition one. So 81 to the power of 1 by 4 plus 8 to the power of 1 by 3, which is basically 3 into 3 is 9, into 3 is 27, into 3 is 81. So 3 plus 2. So the answer is 5. Because what number multiplied by itself 4 times gives you 81? That's 3. And what number multiplied by itself 2 times and 3 times gives you 8? I said before, it's 2. So 3 plus 2 is 5. Suppose we're given a variable, root x to the power of 4, y to the power of 2. What this basically is x to the power of 4 times 1 by 2 and y to the power of 2 times 1 by 2, because whenever you're in a square root without any other sign, like number out, it would be this. So which should give you x to y, which is our answer. So next, let's go over polynomials. So a monomial is a number, variable, or product, and variables with a whole number exponents. A degree of a monomial is the sum of exponents of the variable. A constant number has a degree of 0. So monomials include 5x, negative 7xy, and 0.5x to the power of 4. Not monomials are like negative 0.3x to the power of negative 2, which include a lot of negative numbers, 4x minus y, since there are two values. So, and 2 over x to the power of 3. So, a polynomial, on the other hand, is a monomial or sum of difference of monomials. The degree of a polynomial is the degree of the term with the greatest degree. So, what that basically means is, suppose we have 4x squared plus 3x squared plus 3. So over here, 4 is to the power of 0 or 1. Or actually, 4 has no power, so 4 will be cut out. X has the power of 2. 3 cut out. X also has the power of 2 over here, and 3. So the degree of this monomial is 2. And polynomials can also be categorized based on the number of digits they have and its degree. So if a degree is 2, as we saw before, then it's a quadratic. And we also saw that there are 3 digits, which would make it a trinomial, since it has 3 terms. So it's a quadratic trinomial. So to look at it in a diagram, here's all of like the different combinations. So someone said this white box. You'll see all the different combinations. So it could be a linear polynomial when it has 4 or more, which basically means its degree is 1, but the number of terms is 4 or more. So now let's look at a few problems. So match each polynomial with on the left with its classification on the right. To x cubed plus 6. So over here we would say 2x to the power of 3. So obviously 3 is the highest power because 6 and 2 have no power. So its degree is its degree would be a cubic. So it's a cubic and it has 2 values. So cubic binomial is what its classification would be. So next, 3x cubed plus 4x squared minus 7. So over here 3, so it's also a cubic, and we see 3 digits here, so it would be a cubic trinomial. And finally we have 5x squared minus 2x plus 3x to the power of 4 minus 6. So here we see 4 is the highest power, not 3 but 4, and we have 1, 2, 3, 4 digits. So it's 4 and 4. So it's basically, if we look at our diagram from before, it's a quartic polynomial since it has 4 digits. So 4 or more is a polynomial. So the answer is that it's a quartic polynomial. So the standard form of a polynomial is basically the order it is written in, where it's written from the greatest degree to the least degree. So suppose we have 9x to the power of 3 plus 7x to the power of 2 plus 3x. So we have this over here, but the terms are written from the greatest degree to the less degree. And when written in standard form, the leading coefficient, the number before it of the monomial with the greatest degree. So we have 9x to the power of 3. So this is already written in standard form because this has the greatest degree, so it's written first. And this is the leading coefficient, so 9 is the leading coefficient. And then it's written in descending form, so x to the power of 2 and x. So 9 is a leading coefficient, and 3 is the degree. So suppose we have another problem. Suppose they're asking us to, in standard form, write 5k squared plus 7k cubed. So over here, what obviously comes first is k cubed. So 7k cubed plus 5k squared. And 7 is the leading coefficient. So yeah, that's all I have for this video. I hope this video helped you with basics of polynomials and exponents. And yeah, thanks for watching, and I hope I see you next time. Bye!